Right.
Where would 45 lie on here?
Rutler.
Right about there. Right? So what did we say? It was 0.7. So at 45 we have about 0.7, which would be probably around here. Right?
Right.
Everyone do sine of 0. 0. So 0 would be right here. Sine of 90.
1.
Sine of 90 would be 1, correct. Thank you. Be up here. Sine of 180.
0.
270.
-1.
And just for kicks, let's do sine of 225.
-0.7.
-0.7 around here. What would be sine of 360?
0.
0. Let's do 135.
0.7.
0.7. So, as you can see, what happens is the value goes like this, and this is also called a sine curve. So it doesn't matter what angle you pick, the sine of that will follow somewhere on this curve. So what does that mean in reality, just looking at this circle? This is at 45, we saw that the sine is a certain ratio of 0.7 here. Right? If I were to say now 30, if this was 30 here, this is 60, this is 90. Sine of 30 would be what? Somewhere between 0 and 0.7, which is what? What else you put it into your calculator? 0.5, right? So didn't we say that that was already 0.5?
Right.
Now if I were to take another triangle and say, 60. That was a 60-degree angle from here to here. What's sine of 60?
0.8.
0.8. So it's a little bit higher between there and there, right?
Right.
When we get to sine of 90, what do we get? 1. Right? And let's look at that. Let's say we had a triangle. You can't really make a triangle out of it, but let's say we had it like this, right? And what is sine? It's opposite over hypotenuse, right? If we're talking about the sine of the 90, what angle is opposite? The hypotenuse, right?
Right.
So it's hypotenuse over hypotenuse. What's that going to be?
1.
1. That's why it equals 1 at 90. And then we start coming back this way, right? Let's say this is 45. Sorry, it's not going to be 45. It's going to be, that's 45 there, so this must be 45 here. This must be 90. 90 plus 45 plus 45 is
180.
180. So what's the sine of 180?
0.
Comes out to 0. If you were to say sine of, let's say 90 plus 45, 135. So this angle, you're looking at this triangle, but this is the angle, 135. What's sine of 135? It's going to be 0.7. So that's why it does this cyclical pattern over and over and over. That's how we get sine. So that's kind of tying in the theory that I wanted to.
Okay.
Same thing, you can say same thing about cosine. Say we had these triangles, but we're looking at cosine, which is adjacent. Say we had this triangle here. It would be adjacent over hypotenuse, right? Whatever this hypotenuse is. In that case, you'll see that it follows kind of this pattern. It does this thing where cosine of 0 degrees is 1, cosine of 90 is 0, cosine of 180 is -1. So it also follows a cyclical pattern, but it's instead of starting at 0 and hitting 0 again at 180, it starts at 1 and hits 1 again at 360. Right?
Okay.
That's sine and cosine. Now let's go into the inverse cosine and the inverse sine. So say, for example, I'm going to erase all this. Oh, I should have kept that. Damn.
Well, we can still see it.
All right, let me just redraw it. Are you guys getting tired, or? This so this is 1, minus 1. All right. If I said that you have if I say the sine of some angle equals 0.5, what is the angle?
So you're working it backwards.
We're working it backwards. So we're using this graph and we're saying, well, it's 0.5, so we know it's hidden here. It could be this angle, it could be this angle. Right?
Yes.
So
So
typically we're going to just say it's the first angle that we see, because this goes on forever and ever and ever. You can say, so in this case, what would it be?
Well, 30, because we did that
We
earlier.
know it's 30. But alternatively, in your calculator, what you can say is, you can say sine inverse of 0.5 equals
yes.
theta.
0.5 second. Yes.
0.5 second sine or something like
Yeah.
that, and you should get 30. Right?
Right.
This equals 30. So, really, how do we use trig? So, trig is basically, if you're looking for a ratio, you say the sine of an angle equals a ratio of one leg of the triangle to another. That other leg may be a hypotenuse. The inverse sine, or the inverse cosine, or the inverse tangent is saying you have a ratio, what is the angle that is representative of that ratio? So, tying this all into radiotherapy, when do we use this? There's that one formula that I've given you, which is E of your gamma, after equals E of your gamma before over 1 plus, what is this? I think this is E gamma here, 0.511, 1 minus cosine theta, right?
You don't need the MEV in there, or is that not? Is that just for that one?
I just put the
particular-
MEV in there for your benefit, such that you know these all have to be an MEV.
Okay.
Right? So, often we see, this is related to Compton scatter, because that's the only way photons interact, right? So if we have a photon coming in, and it hits a little electron just sitting here hanging out, I had to draw this little grid. We can say the electron goes off in this direction, and the photon comes off in this direction with less energy, right?
Right.
That's theta right there. The angle between here and here. Right?
Mm-hmm.
So, typically you'd say, okay, if this went off at 30 degrees, and you know your incoming energy is E equals 2 MeV, right?
Mm-hmm.
You put 2 here, you put 30 there, you do cosine of 30, which gives you a fraction of ratio, right? So then you know 1 minus that ratio, you plug it all out, you're going to get what the energy afterwards is of that photon, right? Alternatively, they can say, hey, you have an energy that comes in with 2 MeV, it leaves with, let's say, 1 MeV. So E after is 1 MeV. They're saying, what is the angle that it went off at? In that case, you're solving for this theta right here, and you're going to have to probably end up using a cosine inverse of some fraction, some, we'll say decimal, right?
Right.
And that's going to give you in degrees the angle. So let's work out a random problem like that. I think number 5 will probably help us in that regard from our homework.
Yeah.
So everyone want to go through 5 and then we'll call it quits for the night?
Sure.
Well, they don't really give you any numbers.
No, they give you just like one energy, and there's no. You don't know the exiting. You don't know the angle.
Okay. Well, this wasn't
Well, they're
really,
looking
this
for a
wasn't
minimum,
really
so.
the question that demonstrates finding the angle, but it is a conceptual thing. Well, let's look at it this way. It says, what does A say? What are we looking for?
The minimum energy of the scattered photon.
So what would be the minimum energy of the scattered photon? So if we want to minimize this thing here, right? That's the variable we want to be smallest. How can we achieve that here in this formula? What do we have to manipulate in this formula in order for this to get really small? Naturally, I would say we want the denominator to be very large, right? Because if you have a really large number in your denominator, then you're going to be subtracting this number by a large number. This is going to be small.
So like a smaller angle, like your smallest angle would give you.
No, so that's just, now you have to ask the question is, what angle will maximize the value of that right there?
What angle will maximize the value?
Yes. So we want this to be very large. So we're doing 1 plus something, right? This thing right here.
Mm-hmm.
This 1 we can't change. This we can't change. This is the only thing that we can change. The angle at which that photon is going off. So if we want this thing to be large, right? So let's rewrite just this part as the crucial part. Right? If we want this thing to be large, we want this thing to be what? Large as well. We don't want this thing to be small. So the problem is, what's cosine of an angle is always going to give us what?
A decimal.
It's always going to give us a decimal because it's a ratio, right? So it's always going to give us a number less than 1. Right?
Right.
So really we want to, if we want this whole thing to be large, we want this whole thing to be large or small.
Oh, you want it to be small because you're going to 1 minus something. So
Exactly. So she wants the cosine of something to be very small because then this whole term, 1 minus that small thing, will be very large. So we want cosine of something to be very small. Right?
Okay.
What angle gives us a very small number for cosine of something? Cosine of what angle is a very small number? Let's go back to our graph.
Yeah, you said 0 was a 1, right?
So it starts here
at 1.
and it goes like this. This is 360. This is 180. This is 0.
So 90 will give you 0.
Because this is going to be a negative 1. This is going to be a positive 1. This
Right?
is going to be 0.
yeah, 90 will give you a negative. I'm going to give you 0.
90 will give you a very small number. However, what's smaller, negative 1 or 90? Negative 1 or 0?
Smaller is negative 1.
Smaller is
Yeah.
negative 1.
Oh.
So really, what is the smallest?
180.
180.
Yeah.
So,
Oh, sorry.
what was that?
I was going to say, this only works with 90-degree triangles, right?
Yeah, trigonometry, sine, cosine, tangent. We're talking about 90. We're talking
Can
about
you
90
have
degrees.
an angle that's 90 and then 180? I mean, is that...
Mm-hmm. 0, 360, 90, 180, 270. So if our photon came in this way, it came out this way. Backscatter.
That's not a 90-degree triangle, though.
What?
I thought we had to use a 90-degree triangle for all of this to work.
No.
Where's my triangle?
It is. Remember, again, we talked about how they're like this. You can have a triangle like this, too. It's a circle.
Okay.
And we're looking at ratios of if you were to make one leg of that triangle over another. So in this case, all your legs are wrapped over each other. You have the leg equal to the hypotenuse, right? It's kind of a conceptual thing, but
Okay.
see, that analogy of triangles falls apart as you reach your cardinal angles of 0, 90, 180, and 270.
Okay. Yeah.
But in reality, what you're saying is you have 3 legs of your triangle overlapped over each other,
Okay.
right? So anyway.
I'm trying to visualize the 180. Gotcha.
Is this the question, the minimum energy of the scattered photon, the maximum energy of the recoil? We're sort of talking about if it comes in and it comes right back at you, you have more energy left than if it scatters off into an angle.
So, in this case, you know, we basically discovered that this is going to be very small when the angle equals 180, because that's when you'll have this term being smallest. Because what's happening is you have 1 minus -1 is basically 1 plus 1 is 2. 2 times that number is very large. 1 plus that number is large. This divided by that large number is very small. So then we get the thing, we're losing, we lost the most amount of energy because the energy coming back of that photon is very small. So a 180 degree or a backscattered photon is a point where you'll, the question here is, how do they phrase it? The minimum, that will be the minimum energy of the scattered photon.
A roundabout way of asking this question.
So the next question is, what is the maximum energy of the recoil electron? We never actually solved this, but in this case, let's solve A using our formula. Want to solve A? 5A? What do we have? What are we looking for?
20.4 keV. We have 24.4 keV.
Okay, and what are we looking for?
The minimum energy of the scattered photon.
Yep, and what else do we have? This whole spiel was about finding
Cosine. We have a -1.
-1, or finding the angle that minimizes that. So what do we have? We have our initial energy is equal to 20.4 keV, right?
Right.
We have our theta is equal to 180, because that's what we determined would minimize
it.
the energy of our photon.
Right.
One thing to keep in mind here is I use 0.511 here, that's MeV, so either we can make this 511 keV, or we can convert this to MeV.
keV.
Let's just keep it as keV. So instead, change the formula to 511. So plug it in, what do you get? Plug in all your values.
Really? .08. I don't know if I did that right. No, hold on. 9.8 keV. That's not right.
Anyone else?
Am I supposed to be doing 180 cosine and then that number minus 1? I'm confused by that.
1 minus that number. Remember in your calculator?
180 cosine.
Mm-hmm.
Okay.
It's really cosine 180, but your calculator makes you type it in the opposite way.
Okay.
It's the cosine of 180 degrees is what that is.
Which
the way
is
to say it.
-1, so 1 minus -1.
Is
2.
correct.
Okay.
I got like 18.9.
18.9 is what you should have got. I'll wait till everyone's finished before we move on to the last part of the question. problems?
I can't get that number, but that's okay. I can plug away at it later. It's probably something to do with my math.
$18.9. Is everyone getting it? Kinda. Okay, so now the next part of the question is, what is the maximum energy of the recoil electron?
Can't be any bigger than 20.4.
Mm-hmm. Agreed. Now, one way to look at it is, you had a photon coming in, hits an electron. The electron went off at some direction. Oh, electron goes off in some direction, and the photon comes back in this direction. This we know, if this is 180, that this minimizes the energy